Magandang araw. This is Ma'am Badet. So we are through in discussing algorithm. So for today, we will continue the discussion with flowchart. To begin with, algorithm for large problems becomes complex and thereby difficult to write the code. So that's why problem analysts found flowcharts. So why do we use flowcharting or flowcharts? So it's an easier way to solve the problem. And then each step is represented by a symbol and contains a short description of the process steps within the symbol. And then flowcharts are linked by arrows to represent data flow. So there are other names of flowcharts. It can be called as a flow diagram, process chart, business flow diagram, etc. So flowcharts can be used for the following aspects. So in defining and analyzing the problem, so to help you build a step-by-step picture of a process since it is represented in graphical form, and then to find the areas of improvement in the process. Now, what are the advantages of using flowcharts? Of course, for effective communication, and then for effect analysis, and then for effective coding. So it's easy to locate the errors, especially when you're doing debugging. And of course, for alterations and modifications. So if alterations are required, the flowchart may require redrawing completely. So for us programmers, we use flowchart as the blueprint of our programs. So if you're using the blueprint as engineers, we do have a blueprint. As IT practitioners or programmers, we use flowcharts. So there are different types of flowcharts, but I'll be discussing two. So the first one is the system flowcharts. So by definition, it is used by system analysts to describe the data flow and operation in a data processing cycle. And then it defines the broad processing in organizations, showing the origin of data filing structure, processing to be performed, and output to be generated. So in a system flowchart, so when we say data filing structure, so databases are included, and then processing to be performed and output to be generated. So there are other symbols that is being used, but we will not be tackling those symbols. It's what do you call this? These are symbols for advanced flowcharting. Since you are engineering student and your orientation is basic programming, so I will not be dealing with the different advanced symbols for flowcharting. Now the next one is the program flowcharts. So these are used by programmers. So this will be the one I'll be discussing for you, but we will be dealing with basic symbols. Okay? So since we will be using C language, so having a good foundation in algorithm writing and drawing flowcharts will be an advantage in programming, of course. So the first thing that you have to learn are the symbols used in flowcharts. Like in algorithm, we have basic statements that we have to use in creating or writing an algorithm. Of course, here in flowcharting, we will be dealing with symbols. So the flowchart being a symbolic representation, standard symbols is used for each specific operation. So these symbols are used to represent the sequence of operation and flow of data and documents required for programming. Okay, flowchart, the flow of the flowchart should be from top to bottom, left to right. Okay, so I repeat. So the flow of the flowchart or the symbols should be from top to bottom and or from left to right. So here are the symbols used in flowcharts. This is the terminal symbol or what we call the start or end of the program. And then for computational steps or processing function like assignment statements, formula, we use the rectangle symbol. And then for input and output operations such as printing and displaying output or reading or input, we use the input-output operation or the parallelogram. Now, the initialization block is used for initializing variables. And then for decision making, such as, so I have discussed in algorithm that we are dealing with, we will be dealing with different kinds of decision making, such as the conditional order, of course, and then the iteration, we will be using the diamond symbol. This one is the on-page connector. This is connecting flowcharts on the same page, while off-page connector is this is used for connecting flowcharts on different pages. Okay, so these symbols are used for program flowcharts. Okay, so program flowcharts. So this symbol, while the remaining three are used by systems analysts for systems flowchart. But of course, so this remaining three is for advanced flowcharting, which also incorporates these symbols. Okay, but for now we will be using these symbols for our program flowchart. What you see on your screen is the website of SmartDraw. SmartDraw allows you to create professionally looking templates such as organizational chart, data flow diagrams, state diagrams, and of course, flowcharts. So for this session, I will be using this website for demonstration. And for your learning continuity, the same problem sets will be used for this. So for our first problem, write a program or draw a flowchart that prints Hello World to the screen. So we have written the algorithm of this problem in our previous lesson. It has 3 steps, of course, consists of the start and an ending. As a review, your algorithm should have a start and an ending. The same thing with the flowchart. It should have a start and an end. So the problem only requires you to display the words Hello World on your screen. So let me demonstrate to you the flowchart of this algorithm. So of course, to represent step 1, so use the terminal symbol or the oval for your step 1 and then label this with start. Then right after that, to represent step 2 in flowcharting, which is print Hello World. So take note of print. It says that you should display the words Hello World on your screen. The symbol that represents this step is the data symbol or the input-output symbol. And of course, to show the flow of data, you use arrows or data flow to connect the first step to the second step. Okay, so input-output symbol uses parallelogram to denote that this step prints or input a variable. It may print a text. So defining a text is it is enclosed in double quotation mark. Okay, so just label it with print Hello World. And of course, add an arrow to represent the data flow. So the last step will be end. So this is the flowchart of our algorithm. So to represent again, you use the oval shape or the terminal symbol for start and end. And if you want to display something on your screen, you want to display a sequence of text or variables, you can use the word print or the word output. Of course, inside a parallelogram which represents the data symbol or the input-output symbol. So for our second problem, write an algorithm and draw a flowchart that asks the user for their name and greets them with their name. So the sample greeting will be hello and then the name that you have entered. So let us analyze the problem first. When you see here, the variable name is given in this problem. It is denoted by the open and close parenthesis. And then as a review again, so when you see a text enclosed in double quotation marks, it means that you're going to print that set of string. That is the difference between a variable and a set of string. So for example, what will be displayed on the screen is the word hello and then the name that you typed on the keyboard. So its algorithm has 4 steps. Of course, the start, and then step 2 will be read name. So if the variable is given, be consistent with your variable names. Use that variable name. But if the variable is not given, for example, number, you have the option to choose any variable names that you want, provided that you follow the rules in naming variables. And then, after reading the name, you can now print the greetings. So the word hello, and then the value of the name that has been inputted on step 2. And then step 4 is end. To draw this in flowchart, so again, we will be starting with the start and end symbol, or the start symbol. This is the terminal symbol. Label this with the word start. And of course, add an arrow line. Since we will input a variable, or we will read a variable, the output and the input and output symbol has the same symbol, which is parallelogram. So they will only differ with the label. So type the word read name. Then after that, we will continue with step 3, which is print hello and then the variable name. So again, what we will be using is the parallelogram for printing. So as what I have said a while ago, input and output symbol utilizes the parallelogram shape. So type print the greetings and then comma followed by the variable name. The last step will be end. So as a review, so you have your step 1, which is start, and then to denote or to show the counterpart of read or input in algorithm, we use the parallelogram symbol labeled by read name, or you can use the word input instead of read. And then of course, after reading the name, we are now ready to issue the command hello name, or print the greetings with the format of hello and then comma the name that you have read on step number 2 and then end. So this is the counterpart of, or this is the representation in flowchart of the algorithm for problem number 2. So for our next example, the problem is write an algorithm that adds 2 numbers represented by the variables a and b and then print their sum. So we have written the algorithm before in our topic in writing algorithm. So we will represent this or draw a flowchart for this problem. So we have 5 steps. Of course, it should the flowchart must begin and end, must have a beginning and an ending. So step 1 is start. So to represent this, use the terminal symbol and then label it with start. And right after this, step 2 is read A and B. So we will be reading values for A and B. So the symbol that we will be using is the data symbol or the input and output symbol represented by a parallelogram. But then don't forget to draw the arrow to represent the flow of the data. So read A, B. Again, this represents the process of inputting or giving values for A and B. And then right after this, so step 3 in our algorithm is add A and B represented by the formula sum is equal to A plus B. So draw an arrow, and then we will be using the process symbol. So the process symbol represents computation, assignment statement. So for this, since we will be using a formula, we will be using the processing symbol. So just type sum is equal to A plus B. And then step 4 will be print sum. So again, we will be using the data symbol or the input-output symbol. And just type print sum. So be consistent with your variable names. So if you use a capital letter here for sum, for S, so be sure that all throughout the flowchart, you will be using the same variable. And then after printing the sum, you are now ready to end the flowchart. So again, you will be using the terminal symbol. So this is the this is the flowchart for our problem number 3. So I have here another example. Write an algorithm that reads the student name, S name, midterm grade, MG, and final grade, FG of a student, and then compute the average represented by the variable AVE. So AVE is 60% of FG or the final grade and 40% of MG or the midterm grade. And then it requires you to print the student name and the computed average. Now here is the algorithm that we have written before. So step 1 is start, and then after that we will be reading the value for S name, for the midterm grade, and for the final grade. Now that we have the midterm grade and the final grade, we are ready to compute for the average, which is represented by the formula AVE is equal to MG times 0.40 or 40% plus FG or final grade times 0.60%. And then after computing the average, we are now ready to print the student name or S name and then his or her average and then end the algorithm. Now, the next thing that we will be doing is to draw its equivalent flowchart. So let's start by drawing the terminal symbol. Label it with start, and then of course read S name, FG, and FG represented by the data symbol or the parallelogram. So just type read S name, MG, FG separated by comma, and again be consistent with your variable names. So the next process is compute for the average. So this time in flowcharting you just have to write the formula. So since we will be using the formula, so draw the process symbol to denote that we will be having computation. So just I'll just copy it. I'll just copy the formula. So this is the formula for computing the average. So let's make this neat and clean. So average is equal to 40% of midterm grade plus 60% of the final grade. Then after computing for the average, so we are now ready to print the values for S name and the computed average, which is represented by the data symbol, or the input and output symbol. So we have to print S name and then AVE. Since we don't have any extra area here for our drawing, so remember that the flow of your flowchart must be from top to bottom and then from left to right. Okay? So we will add a flow line and then a terminal symbol to end our flowchart. So this is the flowchart for our fourth problem.